If you're an electrician or electrical apprentice, you've probably been called to a GFCI that keeps tripping. Sometimes it's protecting people exactly as designed, and sometimes it's pointing to a wiring issue that needs to be tracked down. In this video, I'll cover the 5 most common reasons GFCI receptacles trip, how to diagnose each one, and a few troubleshooting tips that can save you time on the job. The first and most common reason a GFCI trips is an actual ground fault. That's when current leaks from the hot conductor to ground, usually through a person, a wet surface, or damaged insulation. The GFCI monitors the difference between current on the hot and neutral. When that difference hits around 4 to 6 milliamps, it opens the circuit in about 1/30th of a second. That's fast enough to prevent electrocution. If your GFCI is tripping on a circuit with appliances, check for damaged cords, cracked housings, or anything plugged in near water. Unplug everything, reset the GFCI, then plug items back in one at a time. When it trips again, you've found your culprit. Number 2 is having the line and load wires reversed on the device itself. The line terminals are where incoming power connects from the panel. The load terminals feed any downstream outlets. Swap them and the GFCI won't function correctly. It may trip immediately, it may trip intermittently, or it may not protect the downstream outlets at all. Before you pull a device, verify voltage at the box. Hot to neutral should read 120. Hot to ground should read 120. If you've got voltage reversed, that tells you something upstream is wrong, not just the GFCI itself. Always verify before you swap. Third on the list, neutral wire issues. A shared neutral, also called a multi-wire branch circuit, can cause a GFCI to trip if it's not wired correctly. When 2 circuits share a neutral, and they're on the same leg of the panel, the neutral current adds instead of canceling. The GFCI sees an imbalance and trips. This is common in kitchens and older homes. The fix is to make sure the 2 hot conductors in a shared neutral circuit are on opposite legs, meaning they pull from different phases in the panel. If you're working a panel and you see a shared neutral, that's your first thing to check. Isolate it, verify the phases, and you'll save yourself a callback. Number 4 is moisture and environmental conditions. Outdoor GFCIs, bathroom outlets, and any receptacle near a water source are exposed to humidity, rain, and condensation. Even with a weatherproof cover, moisture can find its way in through cracked gaskets or missing seals. If a GFCI is tripping on a covered outdoor outlet, pull the cover and check the inside of the box for moisture or corrosion. Check the weatherproof gasket. If it's brittle or missing, replace it. Look at the receptacle itself. If you see pitting or corrosion on the contacts, the device needs to come out. And don't overlook pool equipment, spa wiring, and irrigation systems. Those circuits run in wet environments by design, and they'll trip a GFCI if something degrades. Number 5 is a defective GFCI, or faulty connected equipment. GFCIs have a finite lifespan, typically around 10 years in normal conditions, less in harsh environments. An aging GFCI may become hypersensitive and trip below its rated threshold, or it may fail to reset at all. Before you swap the device, test your connected equipment separately. Plug each appliance into a known good outlet and run it. If one trips a standard outlet or shows a fault on a tester, the equipment is the problem. Common offenders are refrigerators, washing machines, and sump pumps. Anything with a motor can have insulation breakdown that causes leakage current. Replacing a GFCI without diagnosing the root cause just masks the problem. You'll be back. A few quick tips before you wrap up a GFCI call. First, always test the GFCI function with the test and reset buttons before assuming it's bad. A lot of GFCIs just need to be reset. Second, use a circuit tester. A $2 plug-in tester will tell you if the outlet is wired correctly and if the GFCI is protecting downstream outlets. Third, document your findings. If you're on a service call, note what tripped, what was plugged in, and what the fix was. That documentation protects you and helps the customer understand what happened. Fourth, if a GFCI is tripping with nothing plugged in and no load on the circuit, the issue is in the wiring, not the connected equipment. Start at the panel and work your way out. That's the 5. Ground faults, wiring reversal, neutral problems, moisture, and defective equipment. If you can systematically rule out each one, you'll close most GFCI calls in under 30 minutes. If this helped you out, drop a comment, hit subscribe, and check out the rest of the series. We cover everything from panel troubleshooting to load calculations, all built for working electricians. Stay safe out there.